Lecture 53, The Enigma of Quantum Consciousness Narrator. What if the very fabric of your thoughts, your consciousness itself, operates beyond the realm of classical physics? What if the mystery of mind isn't found in neuronal connections alone, but in the whispers of quantum reality that dance through your brain? Welcome to Lecture 53, The Enigma of Quantum Consciousness. Narrator, consciousness remains the most perplexing puzzle in science. How does the electrical firing of neurons, mere matter in motion, give rise to your subjective experience? To the redness of red, the sweetness of sugar, the richness of Mozart? This is what philosopher David Chalmers famously called the hard problem of consciousness. Traditional neuroscience approaches this enigma through classical physics, neurons firing in patterns, creating emergent properties we call mind. But what if this approach is fundamentally insufficient? What if consciousness requires quantum mechanics to be fully understood? Narrator, while conventional neuroscience views the brain as a complex but ultimately classical computer, quantum consciousness theories suggest something far more mysterious is at work. They propose that quantum phenomena, events occurring at the subatomic level that defy our intuitive understanding of reality, may be central to how consciousness manifests. The implications are profound. If true, it would mean that the very thing that makes you operates according to principles that challenge our fundamental understanding of reality itself. Narrator, to grasp these theories, we must first venture into the baffling realm of quantum mechanics. Consider superposition, the ability of quantum particles to exist in multiple states simultaneously until observed. It's as if reality itself remains undecided, hovering in a ghostly realm of possibility rather than actuality. Imagine a quantum particle that can be both here and there at once, not merely moving quickly between locations, but genuinely occupying multiple positions simultaneously in a suspended state of potential. Only when measured does it collapse into a single definite position. Could our thoughts exist in similar superpositions before becoming conscious? Narrator, then there's quantum entanglement, Einstein's spooky action at a distance. When particles become entangled, they form a single system regardless of how far apart they are physically separated. Change one particle, and its partner instantaneously changes in a correlated way, seemingly faster than light itself. This connectedness transcends our everyday understanding of space and time. Might our billions of neurons leverage similar entangled states to achieve the unified field of consciousness that you're experiencing right now? Narrator, the third quantum principle relevant to consciousness theories is wave function collapse. Quantum systems exist as probability waves until observation forces them to assume definite states. This transition from quantum possibility to classical reality remains one of physics' most enchanting mysteries. Some theories of quantum consciousness suggest that this collapse isn't merely a physical phenomenon, it might be consciousness itself. What if awareness emerges precisely at this boundary, between quantum and classical domains? Narrator, several brilliant minds have ventured into these perplexing waters. Sir Roger Penrose, the mathematical physicist, collaborated with anesthesiologist Stuart Hameroff to propose the most comprehensive quantum theory of consciousness. Physicist David Bohm suggested consciousness might emerge from what he called the implicate order, a deeper reality beneath quantum phenomena. Philosopher David Chalmers, while not exclusively advocating for quantum theories, acknowledges they might address aspects of the hard problem that classical approaches cannot. Narrator, but how could quantum effects influence the brain? The answer might lie in structures called microtubules, cylindrical protein lattices that form the internal scaffolding of neurons. These aren't merely structural components. They're dynamic, information-processing elements that help organize cellular activities. What makes microtubules intriguing from a quantum perspective is their hollowed-out, crystalline structure that just might, be capable of sustaining quantum coherence, allowing quantum computations to occur within neurons. Narrator, this brings us to the orchestrated objective reduction theory, or Orch-OR, developed by Penrose and Hameroff. This theory proposes that consciousness emerges from quantum computations in microtubules that reach a critical threshold, triggering what Penrose calls objective reduction. a collapse of quantum states that isn't caused by external measurement but is intrinsic to quantum gravity itself. In this model, each conscious moment represents a quantum computation that reaches completion. Your stream of consciousness is a sequence of these quantum collapses, each representing a moment of awareness. Narrator, for quantum effects to influence consciousness, quantum coherence, the ability of quantum systems to maintain superposition states must somehow persist in the brain. This presents a formidable challenge. The brain is warm, wet, and constantly interacting with its environment. Conditions that typically cause quantum coherence to break down almost instantaneously through a process called decoherence. Yet proponents suggest that certain protein structures might create isolated environments where quantum effects could persist long enough to influence neural processing. Some even propose that the brain might actively employ mechanisms to protect and utilize quantum coherence rather than suppress it. Narrator, skeptics remain unconvinced. The too warm, too wet critique argues that quantum coherence simply cannot last long enough in the brain to have meaningful effects on consciousness. Classical physics, they contend, is entirely sufficient to explain neural activity and its emergent properties. They point out that even if quantum effects occur in the brain, this doesn't mean they're causally relevant to consciousness. After all, quantum effects underlie all physical systems. Their mere presence doesn't imply functional significance. Narrator, yet recent research offers tantalizing hints that quantum effects might indeed play roles in biological systems. Quantum coherence has been observed in photosynthesis, where plants use quantum effects to achieve remarkable efficiency in converting sunlight to energy. Studies suggest quantum tunneling may facilitate enzyme reactions. Birds may utilize quantum entanglement for navigation via Earth's magnetic field. While none of these directly proves quantum consciousness, they challenge the assumption that quantum effects cannot possibly operate in biological systems. If nature has harnessed quantum phenomena elsewhere, might it not do so in the brain? Narrator, beyond the scientific debate lie profound philosophical implications. If consciousness emerges from quantum processes, does this suggest consciousness is a fundamental property of the universe, rather than merely an epiphenomenon of complex information processing? Might consciousness operate at the boundary between quantum and classical realms, somehow bridging these two domains of physics? Could the observer effect, the apparent role of consciousness in collapsing quantum possibilities into definite realities, hint at a deeper relationship between mind and matter than we've previously acknowledged? Narrator, perhaps most intriguing is the question of whether consciousness and reality are truly separable. In quantum mechanics, the observer appears inextricably entangled with the observed. If quantum processes underlie consciousness, this suggests a profound interconnectedness between mind and world. As physicist John Wheeler proposed with his participatory anthropic principle, observers may be necessary participants in bringing reality into existence. We may not be passive witnesses to an independent reality, but active co-creators of a universe that requires consciousness to manifest. Narrator, we've journeyed through the enigmatic landscape where quantum physics meets consciousness, where the laws governing the smallest constituents of matter might give rise to the most profound mystery we know: subjective experience. Whether quantum consciousness theories ultimately prove correct remains to be seen. The debate continues, with evidence accumulating on both sides. What's certain is that in pursuing these questions, we're probing not just the nature of mind, but the fundamental fabric of reality itself. As you contemplate these ideas, consider that the very thoughts you're thinking might be quantum processes unfolding in your brain, wave functions of possibility collapsing into the definite experience you call consciousness. In seeking to understand consciousness, we may be consciousness seeking to understand itself. A cosmic Ouroboros that transcends the boundaries between observer and observed, between mind and matter, between the quantum and classical worlds. Thank you for venturing with us into this perplexing territory where science meets philosophy, where physics meets metaphysics, and where the greatest mystery of existence continues to beckon us forward.